Okay. Hi, my name is Sam Kneckenhofer. I work with Cliff, and this was the project. He wanted to have a set of gears. You can see it better on this edge, actually. So this is first gear in reverse, and then you have other settings like third gear forward, for instance. There's some kind of error. Yep, hold on, I'll fix this. Okay, I think I fixed it. So we have different radiuses. So radii, I guess, is the correct term. So this is a 1-to-1 gear ratio. Here is I think it's like I don't even remember what it is, but it gears down, and I couldn't get it to be perfectly 2-to-1 or 3-to-1, but because otherwise it wouldn't really fit in there. But it does gear down quite a bit. I put that black triangle just so you could see more of what's going on. We went with this is called a bevel gear, where you have two 45s coming together. It's not, a perfect bevel gear, but it's pretty close. So I will walk you through how I built it, starting with this guy because he's a little bit easier. Let's just roll him back. Okay, so this is where I started, right? And I started with a revolve that gave me something like that. So if you look at the sketch, it's just kind of this weird spike shape. These are all 45-degree angles, so since I'm doing a 90-degree overall angle, I did 45s. These are my dimensions, just to keep them with your original dimensions. And so what we're going to do is you do our... Okay, hold on. Sorry about that, my Solidworks crashed. So we've got like this disc thing, and we're going to be cutting teeth through here with a circular pattern. So the first thing I did was I made a plane that is normal to there. And the way you do that is you go to Features, Reference Plane, Plane, and then you choose that guy, and there's a point somewhere over here. So what you do is you put a sketch on like the front plane. Let's go normal to that. And then you do a center line. And another center line. From here, I'm going to keep it collinear with this silhouetted line here, which can sometimes be hard to select. So collinear, and then you merge these 2 points. And now you have a line that you can make your plane orthogonal to, so you exit out of that sketch. Features, reference plane, select that point, select that guy, and check. And you got your plane. But we don't really, I'm going to keep that sketch there just for reference, but we don't need this plane. So then what I did was I just put a real soft fillet around this edge, so it's not, kind of breaks the edge. Okay, now this guy is kind of where we start to get technical. What I did was I did a sketch on that plane, and you can see I did a similar sketch just going the other way. So I guess now that you can see it, we can delete this guy's sketch. So edited this guy's sketch. Okay, I'll hide the relations because there's a lot of them. So just this kind of shape I made this a little bit high just so that make sure it cuts through everything. And then I did a line from here to here, an arc from here to here, and then an arc from here to there. And then I just gave them these dimensions and I kept those consistent across all three of the gear ratios. So exit out of that. And then we've got this sketch, which I showed you before, where it's just collinear and it comes up and hits this point. And you have to actually take a point and put a point there. That's important, because what you do is you make a lofted cut from this up to this point. And if you don't put a point up there, then it has nothing to zero in on. So if you're having trouble getting it to recognize that point, you gotta go and physically put a point in. So you select that, and that gives you a nice cutout. And then I put a center plane in, which select this top face and this bottom face to give me a mid plane. And I did that because I wanted to mirror it. So I just did a mirror of this feature, the lofted cut. And then I filleted something. What did I? No, I suppressed that. I suppressed all of these because they aren't needed. Okay, so then I put an axis here. And the way I did define the axis was it's in reference geometry. And then I did two planes where they meet, and the front and right planes gives me a nice central axis. And then this is where it starts to bog down, as I did a central pattern, or circular pattern, about that axis with these features. And let's see, how many instances? I did 50 equal spacing, and I just based that on, eyeballing it, that, they look pretty equal. And then I cut out the circle. And then I put this little black triangle just so you can see it spin a little bit better. So that is how I made that part. And the next one's a little bit more involved. So here we are again. Oops, I got my gear ratio off a little bit, didn't I? There we go. So I will show you how I made this guy. Kind of looks like a cool little pie. This guy took a little bit of thinking to get done, and it's still not really perfect, but it shows the concept. So starting from nothing, I did a revolve kind of similar to the last one, just with 3 of them. The sketch. Yeah, there's my dimensions. It's kind of like a toothy looking thing. I had a length come out here, 45 degrees up, 45 degrees over. I kept this dimension the same off of the previous one because this was the depth of our teeth. And then I made it come down far enough to where our gear would be able to fit inside of there, the little pointed end of our gear. And then I just instanced these guys over until I had 3 of them. And then I just left the center one thicker just so we have more strength in the center. So revolve that. I did a similar method was showing this plane here with this sketch. You actually don't need these guys just yet, so don't worry about those. But same way that we did the last one, just draw a line from there to a central axial center line. Maybe I do need them. Okay, whatever. That's what I get for screwing around with sketches. And then that allows you to make a plane, just like we did in the previous one. And then we make a sketch. Same exact dimensions, as you can see, as the previous one, exactly the same. And you do a lofted cut. Same method as we did before. And then we put a central axis and circular pattern it in another 50 instances because it's a 1-to-1 gear ratio. And what did I fill it? Oh, I filled it this center, just use these centers just for fun. Okay. I cut out the circle there because I probably was taking a break. I'll show you the dimensions of the circle at least. 3 millimeters. So, in case that matters. So, to get these planes, I'm going to go ahead and hide this plane. It's a little bit trickier because you'll notice down here there's not really anything for me to click on to become, tangent to it. On this plane I had something to be tangent to, this one I didn't. So, what I did was I made a sketch like this, and then I made this plane, plane 2, this plane right here, I made it orthogonal, perpendicular to that point in that center line. And then this guy, I just made a distance, oops, didn't need to put a sketch, put a distance from this plane, 3.5 millimeters. And that put him, approximately where he needed to be. And same story with the sketch. I just did a sketch there. Same dimension. I think I had to make everything see-through to be able to see it with relation to everything else. But you get the point. And then we did another circular pattern. This one took some more eyeballing, where what I did was did the evaluate measure, and I measured that point and that point, got 0.75 millimeters, and then I measure this point and this point, and I get 0.78. It's pretty close, and it's between two values of gears. So I did 36 gears, which is a little over 2-to-1, a little under 2-to-1, I guess. And there's your second, and then you just repeat it again. I'll hide these guys. Show this guy. Again with sketch like this, make your first plane parallel to the sketch there, and then you put your second plane 3.5 millimeters again, I believe. Yep, 3.5. And then you do the same exact sketch as the previous. And you cut it out using the loft technique again. And you do another circular pattern. You're just kind of guessing until you get a good in-between distance, which in this case is 22. So this is about a 2-to-1. That's just how the radiuses work. So those are the two parts. Now to put them together, I made this guy. He's just pretty much an L bracket with circles through it so that I have something to connect to, just for reference. Nothing special about him, but I'll show you the dimensions just so you can make him. Boss extrude, show sketch. Oops, I didn't put any dimensions on it. That is bad modeling technique. We'll go 30.3, 0.14, 32, 27. No, put a point there. Well, it's not very good, but you get the idea of the dimensions. And then I put holes. They're both the same hole. 5 millimeters in, centered, 3 millimeters thick. Cut through, same on both sides. So here we are. So to make this guy, so I'll just make a new assembly from scratch. We'll make a base, our center point, press the green to put it fixed right on the axes, and then we will insert our drive pulley. Mate this guy to be concentric with this guy, flip it around so he faces the right way. And we'll put a distance mate of like, I don't know, 0.2, I guess we're in 0.1. I'm accidentally in inches. I'll come down here and put that in millimeters. Okay, and so what that does is spins around there, and we'll put the driven pulley. I guess they're not really pulleys, they're mates, but same thing. I selected the wrong thing. And we'll do another distance mate. Let's make him 5, maybe 4.75. No, 4.5. Yeah, we'll see how that works. Oops, did I press exit? I pressed exit. Supposed to press the green check mark. 4.5. Okay, and then we just kind of keep meddling with these guys. That's 3, 4, 4.3. Let's try 4.5. No, it's going to be 4. No, edit this guy. Let's make him 4.6. 4.8. 4. Make him 5. That's pretty good. You can see they're kind of in the ballpark. Enough for the teeth to mesh for sure. Let's rotate it till the teeth mesh. And then we are going to do an advanced mate, called, well, not an advanced, a mechanical mate. And it's called the gear mate. And what you do is you select a radius. Oh, here, let me try rebuilding. Something was funky. Nope. The mate mechanical gear. Select that, select that. And so no matter what, these two circles are going to rotate together at this ratio over here. And since we want it to be 1 to 1, they rotate together. Pretty nifty. And so I left this distance mate the same and just moved these guys, moved, this one to that one, to that one, to that one, to that one, to that one. So that is pretty much how I did it. You were asking a question about using hydraulics or mechanical to shift. The way I imagine this thing shifting is to have some kind of way to pull this out, move this to its position, and push this back in. So it'd be something like this goes out, this comes over, this comes back in. And you're going to need some kind of clutch to allow you to do that. But as far as mechanics of moving the gears, I mean, you could do it mechanical, I think, if it's all how you hook up the lever to move the gears. I mean, your clutch could disengage the shaft and move it back, and then your lever could, you have 6 gears, so you could have just 6 positions, so like 1, 2, 3, 4, 5, 6, and each one of those positions moves it further along. So you could do it mechanically, or you could do hydraulically. They both do linear motion. So really, it's just how much time and effort you want to put into it. I would say hydraulics would be simpler, just because you could put a cylinder and be done with it. But there's something to say about reliability on hydraulics. But other than that, if you have any other questions about what I did or why I did what I did, well, actually, I will show you one more mate. I'll do second gear. For the gear mate, I did 50 to 36 because I have 36 gears and I have 50 gears on here, and I did reverse because now we are in reverse. So just something to be aware of. So like I said, any other questions, feel free to ask. Yeah, see you next time.